So let's start from this question. First of all, let us do this question and then we'll move to the graph section. Understanding graphs is very important because whatever we are going to do, whatever physical quantity we are going to talk about, we can represent that physical quantity using graphs. So let's talk about this question and then we'll move to the next topic. So the question says the body is projected vertically up at t is equals to 0 with initial velocity 98 meters per second. Another body is projected from the same point with the same velocity after 4 seconds. Both bodies will meet at t is equals to. Now, in order to solve such questions, we need to first of all visualize that how things are going on. Suppose this is the ground, and from here only we projected the first ball or the object. The velocity of projection is 98 meters per second. So this is the condition when t is equals to 0. So after 4 seconds, this ball A, I can say it must be at a certain distance above the surface, and at the same point, another body is projected with the same speed, 98 meters per second. So first of all, we have to figure it out that after 4 seconds, this body A will be at which position. So in order to do that, we'll use equations of motion only. So far we have following equations. V final is equals to V initial plus acceleration times time. Then we have displacement is equals to V initial into T plus half A into T square. Then we have another equation which says V final square minus V initial square is equals to twice of A into S, that is displacement. So this is the question from motion under gravity. So whenever we are talking about motion under gravity, few of our variable changes, like displacement becomes h, or you can say height, that is the displacement in y-axis. Whereas we talk about acceleration, it is replaced by g, which is supposed to be 9.8 meter per second square. So these are the values that changes when the motion is taking place along y-axis, or you can say this is the case of motion under gravity. So here we'll try to understand that how the position of the particle changes as per the time changes. You might be able to see such questions in the class once teacher is starting with this particular section, motion under gravity of free fall. So we are talking about that only. So after 4 seconds, the position is something we need to figure out. So at t is equals to 4 seconds, we'll try to figure out what is the displacement. The displacement can be figured out using second equation, which will become v is equals h is equals to v initial t plus half a t square. So we have all the variables here given that initial velocity is supposed to be 98 meters per second. Time is given as 4 seconds. Acceleration must be 9.8 meters per second square. So we'll substitute the values and we'll figure it out that what is the position of ball A when ball B is released from the same point. So H is equals to 98 times 4 plus half A, that is 9.8, into T square, that is 16. Now the most important part here is the direction. Whenever this particle is going upward with this velocity, what will gravity tries to do? Gravity will try to pull it back to the surface of Earth. And that's why the gravity, that is 9.8 meters per second square, is taken as negative because the direction of velocity is upward and direction of displacement is going to be downward. Direction of acceleration is going to be downward. So that's why there is a negative sign. This is the first thing that we need to understand here. So H is going to be 98 times 4. So this is around 392. Whereas if we solve this, 9.8 times 8, that too in negative. So 9.8 times 8 is something 78.4. So H is going to be 392 minus 78.4, which is approximately 313.6 meters. So when we have released it, and after looking at it for after looking at the object after 4 seconds, its position will be 313.6 meters above the surface of Earth. Now the picture becomes more clear. Let me draw this diagram once again after the 4 second instant. And after the 4 seconds, we'll figure it out that the position of ball A or the particle which we have projected for the first time has changed. So it can be represented by this. So at t is equals to 4 seconds, another body is projected with 98 meters per second. But the first one is supposed to be at this point, and the distance between the first and second one is going to be 313.6 meters. Now the question is at what time they're going to meet at the same point. So first of all, we need to understand the motion. So just imagine you have thrown something vertically upward. So how that project will move? That projectile or the object which we have projected, but it will move like this. First, it will go up, then it will go down like that. This is how it is going to move if we have thrown something vertically upward. So when we are throwing this particle vertically upward, it might be going up, and after going to the highest point, it might be coming back to the some position. During that cover time interval, this object P must have reached up. So we can say that there is some line at which both projected object will be meeting. But the direction of velocity for the second one must be upward, but the direction of velocity for the first one must be downward. So the final velocity for B is going to be upward, whereas the final velocity for A must be downward. So we have to talk about that at what time they are going to meet. So in order to do so, first of all, we again have to figure it out that what is the maximum height this object can cover when it is going from point on the ground with 98 meters per second of velocity. So in order to find out the maximum height, we'll use third equation of motion. Let's see how we can do this. So to find maximum height attained by the projected particle, we'll use V final square minus V initial square is equals to twice of negative of G into H. This is what we can write here. So the final velocity at the topmost point, if you observe, from point on the ground to the topmost point in air, at the topmost point, can I say that the velocity of the object is going to be zero?
Yeah.
Why? Because it is coming down now. If there is any velocity at this point, it must be going upward, but it is not going upward because its velocity has completely drained by the gravity. So it will come zero. So from the point on ground to the topmost point, the displacement is something that is h that is need to be figured out. Whereas the final velocity is going to be zero, initial velocity is 98 square, and it is equals to twice of negative of 9.8 into h. This is what we have to find. So h is going to be 98 times 98 divided by 2 into 9.8. Negative sign on both the sides will be cancelled out. So h is going to be this 9.8 will remove 98 like this. So it is going to be 490 meters. So here it is clearly visible that the maximum height attained by the projectile is going to be 490 meters. It is not going to be less than this. So this answer which is saying that its position after t is equals to 4 seconds is 313.6 meters. It is absolutely correct. So we find out the maximum height it will reach, and this is the answer. Now just think of it. How can we find out the time when both the objects will meet? This is the most important part. Now let us try to understand it. So when I am assuming the A particle, which was initially supposed to be at ground, reaches till point this. Let's say, let me mark this point as C, this point as B, and this point as A. So from A to C, the displacement is going to be this shortest path between initial and final position. This is displacement for A, or you can say the first particle, the first body. Whereas the second body must have reached from point A to point B during that interval. So displacement for this body is also going to be same, right? Can I say that?
Yeah.
And the most important part here is we can equate these displacement for both the masses or both the objects, and whatever time it is there, we can figure it out. So in order to find out that what is the position, in order to find out what is the time when they meet, we have to figure it out that what is the position when they meet. Because the time which we are relating here is going to be get by when they are at same position. So the displacement for both objects is going to be same. So how can we do this? Let us understand. So we can say that the S for the first particle must be equals to S for the second particle. Basically, displacement for first particle is going to be equals to displacement for second particle, like that. So how can we write about this S1? So S1 is going to be, we're using this equation only, U T plus half A T square, which is equals to U T plus half A T square. Now what is this? This is going to be 1, this is going to be 2. Time is going to be 1, whereas time is going to be 2 for the second particle. Everything remains here. So from here, we can actually figure it out that what is this time. So in place of U, I can write 98, that too in upward direction, so it will be positive. T1. For the first particle, the T1 is going to be T plus 4. Why? Because we are observing the motion when particle has already covered some distance during this first 4 seconds of time. It is equals to half. Acceleration is again 9.8. Again, in case of T, we'll write T plus 4 whole square. It is equals to U2T. So U2 is again 98. Time is now going to be T seconds because this is the time for which the second particle has moved. Plus half 9.8 into T square. So now what you have to do is you have to figure it out. You have to solve this equation. And then you need to tell me that what is the time. And that is the time when they will meet. So after whatever seconds it is, you can find it out and tell me. So just do it
Okay.
and let's figure it out. So it is going to be 9 T92 plus the whole thing also get cancelled. So it is going to be 9.8 into 16, which is 156.8 plus 9.8 into 1.5 into 2T into 4. 39.2 T is equals to 0. So if you solve it, you'll get something like that. So we can say the time is going to be 392 plus 156.8 divided by 39.2, which is going to be 14 seconds. So I can say from the beginning to this particular position T, where the position is supposed to be same or the point where they're going to meet. There's something which says it is going to be t seconds. That is 14 seconds. So the time after which they will meet, it will going to be, we'll subtract 4 out of this because for these 4 seconds, this 14 seconds, this object is not supposed to move. The time for which after they will meet is going to be 10 seconds. So you just have to solve the equation. It is a quadratic equation, and this quadratic equation will ultimately be solved by simply using fundamentals of mathematical operations. That's it. So, did you understand this question?
Yeah. I mean, it's a little confusing, but for the most part, I got it.
Yeah, initially it feels a little confusing, but yes, you might see such questions in your upcoming school test or something. So, you said that you were having a quiz last week. How did it went?
Yeah, it was yesterday actually. It went pretty good, but um a lot of people think they did bad, but I think I did pretty good. But I'll wait to see how I did.
So, when you are supposed to get the result?
Probably like early next week.
Okay. So, let's just move ahead. And here we'll be talking about graphs.
Okay. By the way, I have to
So,
leave exactly at 7 because I have the SAT tomorrow. I need to sleep a little early.
you have SAT tomorrow. At what time?
Um, I guess I have to leave at 7:45.
Okay. So, have you prepared?
Yeah, I've prepared pretty well.
All right then. So, now we have to talk about graphs. So, graphs are something. Um, so, in order to represent motion graphically, or I would say, when we are representing different physical quantities with respect to time, with time, such thing came under this graph section. So, there are three types of graphs. Can be distance time graph, like how much distance the particle is covering. Then there must be some displacement time graph.
Mm.
Then we'll have speed time graph. And then we have velocity time graph. Last, acceleration time graph. So these are the five type of graphs we are going to learn in this particular part of the chapter. Also, we need to understand this thing that graphs are something through which we can calculate two things. The first, it can be slope, whereas the second, it can be area under the curve. So do you have any idea what these two things means? Like what is slope? How can we calculate area? Anything?
Um, well, yeah, slope is y to run or y2 minus y1 by x2 minus x1. But in this
Yeah,
case,
you can no, you can use that equation, that definition also if you know that. So slope is something rise and y as axis to the run in x axis. That is pretty fine. That is completely fine. We can also define it in one another way. So slope is something which is defined as the angle made by the point on the graph, angle made by the tangent through a point on a graph, tangent through a point on a graph with x-axis. So that is something which will give us slope. Like for example, suppose we have a graph,
mhm.
and in this graph, the let's say motion is represented by this particular like that. So I'm assuming this is displacement time graph, so I can write it as xt graph. Displacement can be written as x in terms of graphical representation. So at whatever point I have to find it out that what is the slope of this graph. What we can do is we'll first of all choose a point like this one. Then we'll draw the tangent or tangent to the point. So the tangent to the point can be drawn like that. So when we extend this tangent to the x-axis, so this angle, it is going to give us slope. Also, you can say that whatever displacement this particular point is representing in x and y axis. Like for example, I assume that it must have some coordinate x1, y1, whereas initially there might be a coordinate x0, y0. So the slope, as you already know, it is rise over run. So it is going to be what is the rise? Y. Whereas what is the run? X. So slope is something which is given by this. Or we can also remember slope that it is going to be tan theta. So whatever formula you would like to use, you can use in order to find out the slope from any type of graph. That is an important part. Similarly, we can also find out area under the graph. So whenever we are talking about area under the graph, we need to understand that what area we are talking about.
Mm-hmm.
So area under the graph means area under the curve with x-axis only. Like for example, if I consider the same graph from the last page, so suppose these are the 2 points, and between these 2 points only, we have to figure it out that what is the area. So what we are supposed to do? We are supposed to join it with the x-axis. So this particular area is something we call area under the graph. Similarly, graph can be of so many different types. Let's say the position is changing like that. So we have to find the area. How we are supposed to find out the area? We are supposed to find out the area by covering the area which is lying with x-axis. That's it. So that is something you need to understand that what area we are actually talking about whenever we are solving graph related problems. So we'll be considering area which is coming towards the x-axis. Never ever think of taking this area
Mm-hmm.
along y-axis. This is something which is not considered for calculation through any problem here in physics. We'll be considering the x-axis only. That is what we need to understand. Now, one more thing that we need to understand from this particular graph thing. So suppose if we have displacement time graph. So displacement time graph, again from displacement time graph, we can calculate two things. Either we can calculate area, either we can calculate slope. For displacement time graph, slope will give us velocity. That is important. First point. Similarly, from distance time graph, slope will give me speed. That is second thing. So whenever there is a graph and you have to first of all figure it out which graph it is, then if there is a question says that find this. So through graph also you can find that particular thing. Then we have velocity time graph. So velocity time graph will give us two things. First, we'll talk about slope of velocity time graph, then we'll talk about area of velocity time graph. So the velocity time graph slope will give us acceleration whereas the area of velocity time graph will give us displacement. This is the most important type of graph that might be there in your school exam. Last but not the least, acceleration time graph. So these are the four type of graphs that we actually want to study or actually need to study in order to answer any question here in this motion thing. So again, the slope, this will give us nothing. Whereas we talk about area, so it will give us velocity. Now I guess it's pretty much easier for you to understand that how it is going on. The slope of displacement time graph will give us velocity. Slope of velocity time graph will give us acceleration. Whereas if we talk about area of acceleration time graph, it will give us velocity. If we talk about area of velocity time graph, it will give us speed. So this is how you can remember it. Like when we're talking about slope, so distance time graph will give velocity, velocity time graph will give acceleration. When we talk about area, acceleration time graph area will give us velocity, whereas velocity time graph area will give us displacement. So these are the few things that we need to understand here, at how graphs can be used to explain the motion of the given body. So let's see some graphs now, like for different motions, how the graph has look, how graph looks like. So this is the displacement time graph, the very first type of graph. Here, this displacement time graph is a straight line. So what do you think? What this straight line is representing? The straight
Um,
line is something representing, you can say, uniform motion.
yeah.
How can we say that? Because the graph clearly shows that initially, when the time was zero, displacement was zero. As time is increasing, displacement is also increasing. So it must be possible that a particle is starting at point A, it continuously going away from point A. It is continuously moving with some constant velocity v, and because of that constant velocity, it is constantly going away from that point A. So it is a uniform motion, and it is represented by displacement time graph through this straight line, making an angle theta. So whereas here we find out the tan theta, so this tan theta is nothing but slope. So this will give us velocity. So from this displacement time graph, if the examiner says find out the velocity, so we can find out the velocity by simply calculating this tan theta. And tan theta is what? Rise over run. So it is going to be displacement over time. Now from here you can simply see it that this is what the formula for velocity is, displacement over time. So we are doing nothing, but we are actually creating formulas and solving it using different situations. Is it
Okay.
clear?
Yeah.
Similarly, this is another such type of graph. So here, uh, can you see it and tell me that which type of motion this graph is representing?
Mm, like
It is representing non-uniform motion. How can we say that?
what's going on?
So in the uniform motion, the time taken and the distance covered is same. But in non-uniform motion, time taken and distance covered are not proportional. So you can see that later on in a small time also, the particle is covering more displacement like that. So this shows that the both of them are not proportional to be precise. So this is representing non-uniform motion. So at for this such non-uniform motion, at every point velocity will be different. At every point velocity is going to be different. Velocity is different. What does it mean? It simply means that particle is moving in such a way that the distance covered in a given time interval is always different. So here we can say that there must exist an acceleration. So there must be an acceleration. So this is the graph which is representing upward parabola. And this upward parabola is representing non-uniform motion, or the particle is moving with constant acceleration. That is what this graph says. Remember, non-uniform motion. You might see such graphs soon. Let's move ahead. Now, here's the condition. So this is the downward parabola, whereas this one is the upward parabola. What is the difference between these two? The difference between these two is the first one is representing the accelerated state. Like suppose there is a car and the car is traveling on a national highway. So once it started moving in a national highway, what will the driver do? The driver will accelerate to as much as speed which is allowed by that national highway. So this is the graph which is representing the accelerating motion. Whereas suppose this graph, or try to understand this situation. So here what you can say that the driver must be exiting the national highway. So when it is exiting the national highway, it will try to reduce its speed. So this is the graph which is representing retardation or deceleration.
Mm-hmm.
Because here the distance covered per unit time later on section of the motion has decreased. So this shows that particle must have applied brakes, but as the particle has applied brakes, or it was initially moving with it was initially moving with variable velocity, so velocity must be decreasing. So this graph shows that velocity is decreasing, whereas previous graph shows that the velocity is increasing. So these are the few things that you can pick from this displacement time graph. Is it clear?
Yeah.
So here we have represented both of them simultaneously, side by side. So if the graph is going this, so slope at every point is going to be positive. Now, what do we mean by this? So slope means finding angle at a given point. So how can we do so? In order to do so, we'll draw the tangent, and the tangent, whatever angle the tangent make with the x-axis, this will going to give us slope.
Mm-hmm.
So you can see here that for the every line, theta is different. Or you can say the angle made by the given point with the x-axis, or the given tangent with the x-axis, is different. So if it is different, so velocity at each point is going to be different. But the important part here is, as the slope is positive, speed is decreasing, because we already saw this in previous page, that here this graph shows that speed is decreasing. So this is what it says. Whereas in this case, speed is increasing, but the motion of the particle is towards its initial point. So you can say the direction of velocity is negative I cap, and it is going to be positive I cap. So negative I cap means particle is moving from particular position along negative x-axis, whereas positive I cap means it is moving along positive x-axis. It is represented by a positive I cap. It is represented by negative I cap, like that.
Mm-hmm.
Then there is another type of graphs also. So if it is going upward, it means again speed is increasing. If it is going downward, again we can say speed is decreasing. Few more things. Then how can we convert displacement time graph to velocity time graph? So this is the very simple thing. So here we have seen that such graph is representing the velocity is increasing, and we also know that here is acceleration is going to be constant. So if acceleration is going to be constant, velocity is increasing. So if we draw the velocity time graph, we'll simply draw the straight line. So this straight line graph will give us acceleration by simply calculating the slope. So slope of VT graph, or slope of velocity time graph, will give us what? It will give us acceleration. And this will coming out to be constant, because the angle made by the x-axis is not changing, it is constant, so the slope is constant, so the acceleration is constant. This is how we are supposed to think about it.
Um,
Clear?
yeah.
Then again, this graph shows that the velocity is decreasing. We already know this. But if velocity is decreasing, how we are able to represent it? We'll simply represent it by again a straight line, but it is in downward direction this time. If we talk
Yeah.
about the slope will be calculated by again taking this angle theta with the x-axis. Again, always remember for this particular thing slope. For slope, theta will always be taken from x-axis. You cannot take it from any other point. If it is x-axis, you can take it. Otherwise, it will not give us slope. So here you can see the tan theta is going to be something I can say tan 90 plus this angle alpha, or you can say 90 plus 90 minus alpha. So because of this, we'll ultimately get the value of tan theta as negative. It includes some knowledge of trigonometry to do the conversion. But if it is there, if any such question will be there, we'll discuss it.
Okay.
Then, what is the conversion of velocity time graph to acceleration time graph? How can we do so? So we know if it is a velocity time graph and if we want to calculate the slope of velocity time graph will give us acceleration. So if we see that theta, if we talk about the angle, so ultimately we'll be seeing that the tan theta is going to be constant. And if tan theta is going to be constant, acceleration is going to be constant. So whatever value of acceleration we'll get, we'll draw the straight line like that, parallel to x-axis or the time axis. So this is representing that acceleration is constant.
Mhm.
Then another graph of velocity time graph. So here we have already seen that velocity is decreasing. So if velocity is decreasing, so there must be some theta, or I can say some slope, which will give me acceleration. But in this time, acceleration is coming out to be negative. So that negative constant acceleration will be represented by this particular part of the graph. Again, it is a straight line, but as we know that negative y-axis must have some negative value of a, so that negative value of a can be drawn this way.
Mhm.
Then another such type of graph, if this straight line is not starting from the first quadrant of the graph and it is starting from the fourth quadrant, then also the acceleration is going to be positive because ultimately particle is approaching, or you can say particle is moving towards the initial point of its motion. So this is how it is being seen.
Mhm.
Another case, so I'll share this PDF and you can review all the remaining graphs as well. And the thing here is that these graphs are something which you will definitely see in upcoming classes of your high school. But it's better that we do it right. So again, this is the same graph. If the graph was going this way, or if it is starting from zero and going in the negative direction, then also acceleration is going to be negative. So we'll draw the same acceleration time graph.
Okay.
Now here's the question. So the question says variation of velocity of a particle moving along a straight line is illustrated in the figure. The distance traversed by the particle in 4 seconds will be. So how can we find the distance traveled? So as we know that if we have a velocity time graph, so from that velocity time graph, now velocity time graph is the most important type of graph from all of three, displacement time and acceleration time as well. So this displaced velocity time graph is something which will give us two things, but it is first it is going to give us slope, and second we can calculate area in it. So we know that this velocity time graph slope is giving us acceleration. So definitely we are not finding slope, but the area of velocity time graph will give us displacement or distance. So here what we are going to do is we are going to find out the distance by calculating the area of velocity time graph because the graph has given very clearly here. So we have to find out the distance transferred, or you can say the distance traversed by the particle in first 4 seconds. So we have to calculate this particular area. First of all, this one. then this one, and this one. Because here, from here to here, it will take 4 seconds to reach. So how can we find out the area? By simply looking at the figures and using their general formulas to find out what their area is. So this OAH, it is a triangle. So area of triangle is what?
Hmm. A times B divided by 2. Or length times height. Length times width
1
divided
by.
by
What is the area of rectangle?
just length times width.
Just look at what I'm writing. The first OAH is a triangle. So half times base times height of the triangle. Second is ABGH. So ABGH is nothing but rectangle. So we'll apply length, time, breadth. Then BC, or I assume this point to be some P. So BCP is going to be again a triangle. So it is going to be half into 1 into 10. Then PCFG, it is again going to be a rectangle. So it is going to be 1 times 10. Then last CDEF, it is again a rectangle. So ultimately we'll get 10 times 1. Now we'll simply solve it and add them. So it is going to be 10, it is going to be 20, it is going to be 10, it is going to be 5, it is going to be 10. So 10 plus 10, 20, 20 plus 20, 40, 40, 50, 55. So this is going to be our answer. That this much distance it must be traversed by the particle in 10 seconds, in 4 seconds. Does it make sense?
Yeah.
Then there is another graph. Here, the question says it's given a velocity time graph for a moving object. The total displacement of the body during the time interval when there is a non-zero acceleration and retardation. So we have to figure it out that what are the displacement the particle has done when there is non-zero acceleration and retardation. So that is the question. Now, first of all, we have to mark few points on this graph. So this is point A, I assume. This is point B. This is point C, point D, point E. So here we have these following lines A, B, then we can say B, C, then we can say C, D, then we can say D, E. So we have to figure it out that for which line, what type of motion it is. It is a velocity time graph. Again, the velocity time graph will give us two things. First, it is going to be slope, which can be calculated using tan theta. Another thing, we're going to calculate area. Slope will give us acceleration, whereas area will give us displacement. So every time we are solving any velocity time graph or acceleration time graph, we just need to keep this information in mind that what does the area of this particular type of graph gives and what is the area giving us. So if you look at the graph for point A to B, it is a straight line. It is a straight line parallel to time axis. So what is the angle made by this axis with the made by this straight line with x axis? Any idea?
Hmm. Not sure.
It is x axis. It is the graph. So the angle made by the line with the graph is going to be 0
Oh,
because
yeah.
they are parallel. So for
Right.
first case AB, if I try to find out the value of tan theta, it is going to be 0. It means there is no acceleration. So this is the non-acceleration part. But we have to figure it out non-zero acceleration. Similarly, in the second part, from B to C, the graph is going this way, x-axis is going this way. So angle, there must be some angle. So
Maybe
this
like
tan theta, here we can find out the tan theta. So tan theta is going to be rise over run. So what is the rise? From here to here, what is the rise? It is 3.
that's a 3. Yeah.
What is the run? Run is 10. So theta is going to be tan inverse 3 by 10.
Okay.
So what is the value of tan inverse 3 by 10?
Let me do. It's 0.291.
0.291.
You might put it in like degrees or something. I mean ratings. So
If you write it in degrees, it is going to be 18.26 degrees, like that. So this angle shows that there must be some acceleration. And if it is positive, and if theta is positive less than 90 degree, or you can say if it is acute angle, then this will give us acceleration, which is going to be non-zero, positive. So for non-zero acceleration, we got our point. It is going to be B point. B is the point which will give me non-zero acceleration. And retardation. Now we have to figure it out what is the retardation. So let's talk about. So here the acceleration is something which is tan theta, and this tan theta is going to be 3 by 10, so it is going to be 0.3. So here it is 0.3 meters per second square retard acceleration. Similarly for C to D, we can see that the graph is downward, x-axis is this way, so this is going to be the angle. So whenever we are going to find it out, it is going to be negative. So acceleration is going to be negative in this case because angle is greater than 90 degree, and whenever theta is greater than 90 degrees, slope is going to be negative. Just keep this point in mind. For
okay.
D2E again it is a straight line, so it is going to be 0. So we got to know that from B to D, this is the interval during which the total displacement, we have to figure it out. Between what point? Between point B and point D. So how can we find this displacement? By simply calculating the area. Which area? This whole area between point B and point D. So let's figure it out. What is the area? So whatever way you feel like you can use it to find out the area. Let me use one thing. I'll use it in two parts. First of all, this rectangle and then this triangle. So this triangle's area is going to be half into base, that is 20, into height, that is 3. So it is going to be 10 times 3, that is 30. Whereas area for the base is going to be 20 times 1. So 20 times 1. So it is going to be 20. So the total area is going to be 30 plus 20, that is 50 meters. So this is the total displacement of the body during the time interval when there is non-zero acceleration and retardation. So this is all about graph, and these are the important info that you need to have about graph, because later on we are starting projectile motion, or you can say in the next class I'll be starting with projectile motion. So in the projectile motion we'll be using the knowledge of graphs, we'll be using the knowledge of vectors, and we'll be talking about a different type of motion, although you have seen it, but you have not mathematically represented it yet. So that mathematical representation of the projectile motion will ultimately help you to understand the motion in 2 dimensions. Or you can say that is the second part of the kinematics. This is, you can say, almost third or fourth lecture of what we have done so far in our unit 1. So this is the part of this unit also, and later on also we'll be using the same thing.
Mm.
So does all this make sense?
Yeah.